Good morning, all the present, and thanks for the invitation. Next, I am going to present the research work entitled Design of a Portable Interface for Biotactile Feedback Applications. To begin with, I will expose the principle that motivate the development of this project. What is a haptic interface? Well, a haptic interface is a tool that allows a person to manipulate, feel, or perceive objects in a virtual environment. We've noticed that these systems are becoming more and more immersive in our daily activities. That's why the development of projects in this area must continue to advance. There are applications in different fields, for example, communication, navigation, mobile device, vehicles, and medicine. However, the interface that currently exists have a high cost, which make implementation and experimentation difficult. So the design of a low-cost interface that is easily portable for urban mobility application is proposed. Next, I will explain the design criteria of the implemented interface. Several elements are selected. Among the most important we have an ESP8266 controller, which allows the system to be scalable for its communication advantage. We think that this project will contribute in the future research to Industry 4.0. The controller has been programmed in language and supported by the Arduino IDE compiler. In this platform, with an infinity of open source libraries for device recognition. The OLED screen is a device capable of consuming very little energy, and its ability to communicate I2C or SPI contribute to the user a brighter or clearer image for its operation. And in the field of the diffusion of haptical impulses between the many variables of electronic and mechanical devices. The MP3 model is one of the electronic devices that was selected because it allowed many advantages to mechanical devices. In this case, it doesn't need mains compare mechanical devices. And finally, a high-power XHM543 amplifier with 2 channels Class D output allows to amplify the biotactile illusions. Procedure. Firstly, as a verification method, it was realized that the controller should check that the MP3 module has the SD card with the haptical illusions. Now, the haptical illusions are a tool that will allow us to present information to the human being by unconventional means. In this case, by touch was indicate a direction. For the present experiment, we use phantom motion illusion, which simulate the continuous movement from one hand to another hand. Funneling, we simulate a continuous point moving from one hand to another hand. And cutaneous rabbit, we simulate small jumps from one hand to another hand. The hardware was designed to allow the user to perceive the illusion mentioned above. That's why the design device print on the screen a welcome message to the interface and the list of available illusions. Then, to select the illusions, a push button must be pressed, which will allow the signal to be activated indefinitely until the stop button is pressed. The illusion will be reproduced through an audio amplifier and called Java actuators, which are similar to stereo headphones, in order to create the biotactile illusions with the support of the interface. The entire system will be powered through batteries to make the device easily transportable. To test the operation of the interface, an experiment was conducted with the participation of 10 volunteers from the Indo-American University community. The experiment consists of generating tactile illusions by means of mechanical type vibratory stimuli on the skin through the designed portable interface. Using questionnaires, the participants of the experiment report the perception of the illusions. For the proper development of the experiment, each participant was placed in a comfortable place and earplugs were placed to avoid any kind of distraction. Each participant perceived 3 illusions with different change of locations. Each illusion had a duration of 5 seconds and a pause between sessions of 2 minutes. In each pause, participants report the level of clarity of the illusions. The rating scale was from 0 to 4, where 0 means I don't perceive anything, and 4 means perception of movement very clearly. Additionally, all participants report the dictionarity of the stimulus. Through a statistic analysis of the result, it's evident that the design interface allows transmitting vibrotactic illusion to the participant through the vibrotactic stimuli, but the best perceived illusion was the finely typed vibrotactile illusions, which is the type of vibration that simulates a continuous spoon moving from one hand to another. The validation of haptic interface has been successful because it is being able to transmit tactile illusions with a medium level of clarity, with a reliability of 95%, of reduced weight and sight, and easily portable. As future work, we intend to continue with the research for the design of application in urban mobility using vibrotactic feedback. That's all. Thanks for your attention.